In this problem, curve is such that at any point on it, let us take curve like this. At any point on it is normal is drawn. It is normal. So any point here is x comma y. Tangent slope is dy by dx. Normal slope is minus dx by dy. So at let us say at x1 y1, normal equation y minus y1 is minus dx by dy into at any point means x1 y1 we will consider it as x comma y. So this y comma x I will take it as capital X comma capital Y. Normal equation will be for x-intercept y is 0 capital Y. X minus x is y dy by dx, which implies x is x plus y dy by dx. Now relation is square of the ordinate is twice of the product of x-intercept and abscissa. 2xy y dash. Y dash is y, you take it as vx. X dv by dx plus v is dy by dx. V plus x dv by dx is v square minus 2 by 2v. V square minus 2 by 2v minus v minus 2 this. 2v by v square plus 2 dv is dx plus. Log v square plus 2 is minus log x plus log c. Log y square is y by x. And the log c by x. So y square plus 2x square becomes cx, which represents ellipse. If one root of equation is 3 times other, so sum of the roots is 4a, and 3 times of other, then minimum value of alpha into 3 alpha is a plus f. Alpha becomes a, 3a square becomes a plus of a. So 3a square minus a is f a. For minimum, f dash a is 0, that is 6a minus 1. A becomes 1 by 6. So minimum will be 3 times 1 by 6 whole square. 1 by 12 minus 1 by 6 minus 1 by 12. This for minimum maximum, we write f dash x 0. That is by Leibniz theorem. So x will be 2n pi plus r minus pi by. So here you take f double dash x x into minus sin x minus cos x by x values. You take n as 0 plus or minus pi by 2. N as 1, 2 pi plus 2 pi minus pi. N as 3, 2, 4 pi plus pi by 2, 4 pi minus pi by 2. So f double dash, for example, at pi by 2, it is sin 90 or cos 90 0, cos 90, here it is sin 91 minus pi by 2, cos 90 0 by pi square by 4, it is negative. So at pi by 2, it has maximum. That is for n equal to 0, f has maximum. That means it is ruled out. For n is equal to, here it is x is 2 pi plus pi by 2, that is k equal to 2. F double dash x will be, it is 5 pi by 2 sin 9, sin pi by 2 1, cos 90 0. Here x square is 5 pi by 2 whole square, which is negative. So negative means at 2 pi plus pi by 4, 2 pi plus pi by 2, it has maximum. So the suitable option 2, 4, 6 or minus 2, minus 4, minus 6, it has maximum. Let us check even n is minus 2, then minus 1, x becomes minus 2 pi plus or minus f double dash minus 2 pi plus pi by 2. So here it is minus 3 pi by 2 into minus sine minus 3 pi by 2, 0 by 9 pi square by. We are positive into negative, negative. So at minus 2, it has maximum. So first option is correct. 64th one, t is real. Then we have t square minus 3t plus 4 is lambda times this. We have t square into lambda minus 1 plus 3t into lambda plus 1 plus 4 lambda minus 4 0. When t is real, 3 times lambda plus 1 whole square, 4 times lambda minus 1 greater than 9 times lambda plus 1 whole square, 4 times lambda minus 1 whole square. So 3 times lambda plus 1 minus 2 times lambda plus 1, 3 times lambda plus 1 plus 2 times lambda minus 1. So lambda 3 plus 2, 5. 5 lambda 3 minus 2 greater than 0. So that means lambda is minus infinity to minus 5, minus 5 union minus 1 by 5 to infinity. So for these values, if you take 3x minus y plus 4z is equal to 3, x plus 2y minus 3z is minus 2, 6x plus y lambda z is minus 3. Find the determinant 6, 5 lambda. So 3 into 2 lambda plus 15. 1 into lambda plus 18 plus 4 into 5 minus 12. 6 lambda plus 7 lambda. Here it is 45 plus 15. 63 minus 28. 35. So for lambda equal to minus 5, you have a zero possibility. Here it is, if other than minus 5, there is no other possibility. Lambda is minus 5. Then we have t square minus 3t plus 4 is minus 5 times this. 6t square plus 12t plus 24 0. T square plus 2t plus 4. So here roots are complex. But he told here roots are t is real. Therefore, t cannot be minus. Once t cannot be minus, which implies lambda cannot be minus. Here implies determinant value is 7 lambda plus 35, which can't be 0, which implies system has unique solution. So in this problem, let M be A, B, C, D, F, G, H, I. What he given is 0, 1, 2 of A, B, C, D, E, F, G, H, I, which is 1, 0, 0. From this we can say D plus 2G is 1, E plus 2H is 0, F plus 2I is 0. Similarly, 3, 4, 5, M here is A, B, C, D, E, F, G, H, I, 0, 1, 0. So 4D, 3, 4D plus 5G, 4T is 0. 3B, 3A plus 4D plus 5G, 0. 3B plus 4E plus 5H, 5C, 3C plus 4F plus 5I, C. Similarly, here another possibility is 0, 1, 2, A, B, C, D, E, F, G, H, I, in which he given it as 1, 0, 0. From here, D plus 6, 7, 8. It is 6A plus 7D plus 8G, comma 7B plus 8E, 6B plus 7E plus 8H, 6C plus 7F plus 8I. So what is its value? From here, if you multiply it by 2, 6A plus 8D plus 10G is 0. So that is 6A plus 7D plus 8G is minus D minus 2G, which is minus 1. Again here 6B plus 7E plus 8H is there. To multiply this by 2, 6B plus 8E plus 10H. So 6B plus, here you 6B plus 80 plus 10H is 2. At 6B plus 7E plus 8H, 2 minus E plus 2H. E plus 2H is 0, which is equal to 2. So last one, 6A plus 7F plus 8I. Here you multiply this by 2, 6C plus 8F plus 10I is 0. This you can write 6C plus 7F plus 8I is minus F minus 2I. F plus 2I is 0. So this is equal to 0. Finally, answer is minus 1 to 0. It is third option. Here it is. Sigma r equal to 1 to n r into 2r square 5r plus 3. Sigma r equal to 1 to n 2r cube plus 5r square plus 3r. 2 times sigma r cube is this plus n plus 1, 2n plus 1 by 6 plus 3n times n plus 1 by 2, which is equal to this. Comparing n power 4 coefficients, 2 by 4 here is a, which is a is half. Comparing n cube coefficient, here 2n into n square, 2n cube, that is 4 by 4. 2n into 2, 4 by 4, n cube coefficient. Here it is 10 by 6, which is 1 plus 5 by 3, 8 by 3, which is B. Comparing n square coefficient, here 2 by 4, here n square into 1, here n into n plus 2n, 3n, that is 5 into 3 by 6, where n square is 3 by 2. So 8 by 2, 4 plus half, 9 by 2, which is C. Comparing n coefficients, D is equal to here n into 1, that is 5 by 6 plus 3 by 2. So here 5 plus 9, 14 by 6, 7 by 3, which is D. Comparing constants, E is equal to, here you don't get constant, here also you don't get, the value is 0. So B plus D by A, if you consider 8 by 3 plus 7 by 3, by A is half, 5 by half, which is 10, is an integer. So next fourth option is wrong. A b minus 2 by 3 c minus 1. A here is half. B is 8 by 3 minus 2 by 3. C is 9 by 2 minus 1. So 7 by 2. 2 minus half is 3 by 2. 7 by 2 minus 2, which is 3 by 2. So these are in AP. The option is correct. Where point P minus 2 comma 3 and point Q 3 comma 7 somewhere. The point A on x-axis for which PA plus AQ. The point A on x-axis for which PA plus AQ is least. So here, if I consider this as 3 units, where this point minus 2 comma minus 3. So PA distance is same as P dash A. Once you take the reflection, so here you have, in case A happens to be PAQ or collinear, PA dash Q are collinear, then PA plus AQ will be least, that is least. That means in case A is A dash, mentioned distance will be least. So your line equation is y minus 7, 7 plus 3, 10 by 3x minus 3. So 2y minus, here it is y minus 7 is equal to 2x minus 6 or 2x minus y plus 1 0. For A dash, y 0 means x is half minus half. So the point is minus half comma 0. Here is f is differentiable. G is f inverse means G circle of f is, which is identity. So G circle f of x is I of x, which is x. G of f of x is x. G dash of x into f dash x is 1. So what you have to find out is G dash f of 1 into f dash 1 is 1. So from here, f of 1, he given it as 8, 1 by f dash 1. But he defined it as 1 by 8. So G dash 8 becomes 8. So the option is correct. Here, if you take fx as f dash x will be minus 6x square minus 30x minus 20. X square plus 5x plus 4 0 minus 1 comma minus double dash x you write minus 12x minus 30 double dash minus 1 12 minus 30 negative. So at x equal to 1, function has maximum f double dash minus 4 48 minus 30 18 greater. So at x equal to minus 4, F has, which implies it has one local maximum and one local minimum. Here it is 1 plus y square x into dx, 1 plus x square y dy. X by 1 plus x square dx is y by 1 plus x square dy. Half log 1 plus x square is half log 1 plus y square plus 1c. Half log 1 plus x square by 1 plus y square is log c. So log of 1 plus x square by 1 plus y square is 2 log c, which is log c square. 1 plus x square is c square into c square is always positive c square. So it represents family of hyperbolas. As c changes, eccentricity changes. Or let us check x square by c square minus 1, which is 1. So d square is c square minus 1 by c square minus 1. C square minus 1 will be as c changes, eccentricity changes. Here it is y square y double dash whole square plus x square y square minus sin x. Radical power should not be there. So raising to the raising both sides to the power 3, we will have a minus 3xy dash. With the highest order derivative, order p, which is 2, its degree, that is 6. So p will be obviously less than. So for interval, so first we check for a basic minimum x equal to 1, f double dash x we get 4, which implies that x equal to 1, f has a minimum. That the minimum value is f of 1, 5 minus 4. Once interval is given, you have to check at boundary values. 2 into 3 square minus 18 plus 1, 19 minus 12, 7. F of 9 by 2 will be 2 into 9 by 4. So minus 4 into 9 by 4 plus 1. 9 by 2 minus 8. You get minus 7 by 2. 9 by 2. In place of x, you write 9 by it's interval 9 by 2. So that is minus 18 plus 1. Minus 39 by 2. Here it is 2 into 81 by 4. 9 by 2 plus 81 minus 72 by 4. So 1 plus 9 by 4. She is asking minimum among all these. 1, 7 and 1 plus 9 by 4. So the minimum value is 1. So minus 1. Here 73. Sum of number of terms of expansion m plus r minus 1 cr. Here r is 3 variables. n plus 2 c2. n plus 2 into n plus 1 by 2 is 45. N equal to 9. 9 plus 2, 11. Let us take 8. Yes, 8 satisfies. So we'll get 8 CR. So its maximum is for R equal to 4. So its value is 8C4. Answer is 7. A variable circle. Variable circle passes through a fixed point P comma Q and touches x-axis. Here it is P comma Q and touches x-axis. The locus of other end of diameter through A. Circle touches x-axis. Then center is minus G minus F. That is minus F equal to radius. That is P plus H by 2, comma, here F, which implies minus F is nothing but midpoint of Q plus K by 2, which is equal to radius. So here AB is the diameter, which implies H minus P whole square, K minus Q whole square is 2R whole square, H minus P whole square plus K minus Q whole square is 4 times R square. R is nothing but K plus Q by 2 whole square. H minus P whole square, K minus Q whole square, K plus Q whole square. Here we get K plus Q whole square minus this, which is 4KQ. Locus of H comma K is X minus P whole square equal to 4YQ. So this one is sigma cot inverse 2n square, n from 1 to infinity, n is 1 to n is 2 8, n is 3 18, which I can write tan inverse 1 by 2n square sigma n equal to 1 to infinity 2 by 4n square, sigma n equal to 1 to infinity tan inverse 1 plus 4n square minus 1. This I can write n equal to tan inverse 1 plus 2n plus 1 into 2n minus 1, where 2n plus 1 minus 2n minus 1. So sigma n equal to 1 to infinity tan inverse 2n plus 1 minus tan inverse 2n minus 1. So here it is telescopic series. Tan inverse 5 minus tan inverse 3. Tan inverse 7 minus tan inverse 5. So on tan inverse 2n plus 1 minus tan inverse 2n minus 1 all get cancelled out. So tan inverse 2n plus 1, if you add n terms, as n tends to infinity, this becomes the tan inverse infinity, this which is pi by 4.